Did you know that there are 3 key things needed for severe weather? Well, I'll be going over that in this little tutorial to severe weather / storm chasing. I've noticed that there's not a lot of people out there teaching folks just about the common knowledge things about severe weather. Well, that's where I would like to step in and grow people's knowledge just on the basic things needed for severe weather. So kick back, relax, grab a pen and paper or whatever you want to jot down, or just take mental notes, and we'll get right into it to those 3 key things needed for severe storms. Now, the number 1 key thing needed for severe weather, guys, is dew points, humidity. We need the moisture from the Gulf of America to advance northward and reach to the uppermost parts of, let's just say, Iowa. Minnesota, we've been seeing a lot of moisture reaching here into the upper Midwest, Wisconsin, especially Iowa, Minnesota. We've been seeing the dew points reach into the upper 60s, which is not very common for Minnesota in this time of the year. Yeah, obviously we get some heat spells, but usually the humidity never makes it up this far. So that's why we've been seeing such a robust severe weather season up here. Such cool, drier air off to the north in the Canadians. And then we have that surge of moisture and warm air from the south, and you just have those two collide. I won't get too much into it. But anyways, you need at least dew points greater than 55 degrees to create some severe weather, some robust thunderstorms with some thunder and lightning. As further you go up the scale in dew points, you get into the 60s, 70s. That creates even more robust thunderstorms. So dew points, guys, I'm telling you, that's where number 1 forecast, where I've pinned my forecast, are dew points. If the moisture isn't there, the storms aren't there, the energy isn't there. So number 1 thing in Vern's Valley playbook, Damo's playbook, dew points greater than 55 degrees needed for severe weather. The number 2 most important thing for severe weather is a lifting mechanism. Now, I won't get too much into it. I want to keep this very simple for you guys. Now, a lifting mechanism is a low pressure system. Now, with a low pressure system, you have a warm front, a cold front / dry line. So you can kind of count that. That is part of a low pressure system, but that is also a lifting mechanism. Now, within low pressure systems and such, you can have outflow boundaries. Now, an outflow boundary is a change of wind from a thunderstorm. There's such powerful downdrafts from a nearby thunderstorm that it creates a snake almost, an outflow boundary. So if you would just go south of the outflow boundary, it's more than likely coming from the south. You just go north of the outflow boundary, it's coming from the north. That downdraft wind from the other storm. Anyways, lifting mechanism. That's what you need for severe weather. So a lot of these setups, guys, have low pressure systems. With our severe weather setup we just recently had on Friday, that was a low pressure system cold front, right? We had a strong cold front on the backside, and that's what produced those tornadoes and Rochester and Olmsted counties, Dodge County, all of those over there was the cold front. I was targeting the warm sector out in Wisconsin. Now, there's a lot more lifting mechanism with the cold front. That's why you have those tornadoes there. So lifting mechanism is really a key thing, but if you don't have those dew points, what good does the lifting mechanism do? So number 2 thing, lifting mechanism for severe weather. The third and final thing, guys, you need for severe storms is instability. Now, instability is the difference between 2 air masses, right? Now you have a cool, dry air on the northwest quadrant, let's just say. Let's over here, right? My hand. Cool, dry air. And then down here you have warm, moist air. And I'm talking 70 degrees, 60 dew points. And I'm talking up here like 40 degrees, very dry air. And those 2 meet. You have such great instability between those 2. So you need those air masses, very volatile situations. So that's why a lot of times in the in the springtime, there's a lot of that cool, dry air still sitting around up in Canada. So that's why you have these low pressure systems really suck in a lot of that warm moisture on the warm side. But then on the back side, you have that cool, dry air also getting sucked in from the northwest side. So you have those 2 combinations create a lot of instability. When you have a dew point, a lifting mechanism, and that instability all come together, you have an insane complex of storms. Now, if you look back on Friday's severe weather event, we'll keep going back to that because that's in a lot of people's brains still. On that back side of that cold front, guys, if you paid attention, it went from literally 70 degrees to 50 right on its face. So that instability right there, that that sudden drop, that's that instability, that's that dew, that's that cold front, that's that on that back side. So on that warm side, you have a lot of, you can feel it. Like, ah, this is nice. And then all of a sudden the winds change and all of a sudden, bam, it just falls on its face. So that is that instability factor right there with cold fronts in the springtime, guys. So when you have all three of them come together, dew points, lifting mechanism, all that, it just becomes a very wild time in the spring. So I hope you guys took something away from this. Stay tuned for the next little episode I'll be doing. I'm kind of teaching you guys a little by little, mouse crumb by mouse crumb, as they say. So we'll see you guys next time on this little tutorial for storm chasing / severe weather.